Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last video I have explained you about the new topic, that is transportation problem. In that video I have explained you about what do you mean by transportation problem, what is transportation model, and what is the procedure of finding an optimum solution for a transportation problem. Now in this video I'm going to explain you how to find out the IBFS, Initial Basic Feasible Solution. Before that, we will recap points what we have discussed in the previous video. Actually, transportation plays a very important role in any economy, and for business decisions, this transportation is very important. A transportation will have so many problems, so many issues, but a particular type of issue that will be solved by this operation research technique. So what is that issue? A company may have different factories, different origins where goods are produced or supplied, and different destinations where goods are demanded. So there is a source of supply and there is a destination for demand. So how many units should be supplied from each supply origin to different demand destination so that the total transportation cost should be minimum? So for solving this type of problem, we apply this technique of transportation problems, right? So basically, two stages are there for finding out the optimum solution. The first stage is finding out the IBFS, Initial Basic Feasible Solution. After getting IBFS, next stage is to find out the optimum solution. So in this video, I'm going to explain you what are the methods available for finding out initial basic feasible solution. So before explaining further about this, take the screenshot of the points which I have written on the board. Then I'll explain every point in detail. Now, the first stage is Initial Basic Feasible Solution, IBFS. Three methods are there for finding out the IBFS. The first method is called Northwest Corner Rule or Northwest Corner Method, right? This is the first method. It's the very simplest method of finding out the IBFS. So the simplest of the procedure used to generate IBFS is Northwest Corner Rule. In examination, you may be asked a theory question also regarding this Northwest Corner Rule. So whatever I've explained, that will be very important for writing the theory question. Apart from that, we will solve problems also on finding out IBFS by Northwest. It is so called because we begin with the Northwest or upper left corner cell of a transportation table. Suppose this is the transportation table. In this transportation table, you can see the rows S1, S2, S3 are the supply origins. Three supply origins are there. And columns, we have destinations D1, D2, D3. So three rows and three columns. And every row, every cell, we are written the number. The number is transportation cost, right? The total supply of S1 is 120, S2 is 80, S3 is 80. If you take the total 280 units the total supply, and the demand for D1 is 150, D2 is 80, D3 is 50. If you add up the total demand, 280. It's a balanced problem where total demand and total supply are equal. Now these are the cost. These are the cost given. Now in this so-called, we begin with northwest corner or upper left corner of a transportation table. Northwest corner means this is the first cell. We allocate in this first cell, right? First of all, so minimum of the row total or column total. The column total is 150, row total is 120. Whichever is lower, that will be allocated in this cell, right? Then the row or column which has exhausted, which has become zero, will be blocked, right? If row is blocked, we come down to the next row, right? If column is blocked, we move right side. we move right side. The steps in this method are: select the northwest or upper left hand corner cell of the transportation table. Upper left hand means this one. So we have to allocate first of all in this cell. Then allocate as many units as possible equal to the minimum between available supply and demand requirement. Minimum of row total and column total. Row total is the supply and column total is the demand. Whichever is lower, that will be the allocation in the first cell. Then adjust the supply and demand numbers in the respective rows and columns allocation. Then if row is exhausted, block the row. If column is exhausted, block the column. Then if the supply of a row is exhausted, then move down to the first cell in the second row. If the row is exhausted means here it will become 0. If it is become 0, then we have to move down to the next row, right? If the demand for the first column is satisfied, then we move horizontally to the next cell in the second row. For example, if the first column is exhausted, then we move to the right. If column is exhausted, then the column will be blocked. Then we move to the right. Then if for any cell supply equals demand, then the next allocation can be made in the cell either in the next row or next column. If both are exhausted, row is exhausted, column is exhausted, then we move on to the next cell. Continue the procedure until the total available quantity is fully allocated to the cells as required. Like this procedure, we are moving from first cell to the last cell. Last cell is this one. From 8 to 10. Like this, we have to move on allocating. So advantage, this method is a simple, reliable, easy to calculate, compute, understand and interpret. Very simple method. Easily we can make the allocations. But the drawback, this method of assignment does not take into consideration the shipping cost. These are the transportation cost. To transfer 1 unit from S1 to D1 is 8 rupees. To transfer 1 unit from S1 to D2 is 5 rupees. These transportation costs are not considered in this northwest corner rule. That is the drawback. We must consider the cost, but it is not considered. Consequently, the initial solution obtained by this method usually requires several iterations before an optimum solution is obtained. The advantage is easily we can get the IBFS without any difficulty, without any loss of time we can get. But the optimum solution will be far away from this initial solution. You have to make a lot of iterations before reaching the optimum solution. So easily we can get the IBFS, but very difficult, time consuming to get the optimum solution. It will be very far. So many iterations we have to do if we follow this method. Now in examination, if it is specifically asking you to follow IBFS by northwest corner rule, then only you must follow. Otherwise, we are not going to follow this method, right? Now with the help of an example, I am going to show you how allocations will be made by northwest corner rule. This is the transportation table. In rows, we have supply S1, S2, S3. Columns, we have demand D1, D2, D3. And the values given in each cell is the cost incurred to transport 1 unit from S1 to D1, S1 to D2, S1 to D3. Similarly, S2 to D1, S2 to D2, S2 to D3. All the costs are given. The total supply from S1 is 120, S2 is 80, S3 is 80. And the total demand for D1 is 150, D2 80, D3 50. Now we have to make the allocation according to northwest corner rule. See carefully how I am going to allocate. First of all, we begin with the first cell. In the first cell, what is the row total? 120. What is the column total? 150. Whichever is less. 120 is less. So I will allocate 120 here. This is called allocation. 120 I have allocated. So this 120 minus 120 row becomes 0. 120 was the total, complete 120 I have allocated here. So 150 minus 120, how much remains? 30. 30 is the remaining balance in the column. Row total is 0, exhausted. So row is blocked. This row is blocked. We are not going to make any allocation in this row, right? Now we come down. We come down to this cell. In this cell, what is the row total here? 80. What is the column total here? 30. Whichever is less. 30 is less. So I am allocating 30 here. If I allocate 30, this 30 minus 30 will become 0. Here 80 minus 30, it will remain 50. Then column has become 0. So I will block this column. Right? Now I will move on to this cell. I am moving on to this cell. What is the row total here? 50. Column total 80. Whichever is lower, 50 is lower. I am allocating 50 here. This will become 0. 80 minus 50 remains 30. That's all. So here row has become 0. So I am going to block this cell. Right? Now I am coming down. What is the row total here? 80. Column total 30. Whichever is less, 30 is less. So 30 I am allocating here. 30 minus 30 is 0. 80 minus 30, 50. Now you can see only one unoccupied cell is there. Row total is 50, column total is 50. So here I am taking 50 allocations. This will become 0, this will become 0. Now you can confirm all the supplies become 0, all the demands become 0. Now this allocation is called northwest corner rule. Northwest corner rule. Starting from the first cell and ending in the last cell. That's all. This is called northwest corner rule. Now the second method is least cost method, LCM. The least cost method. The allocation according to this method is very useful as it takes into consideration the lowest cost. In northwest corner rule, we have not considered the cost. Simply we have allocated. But here least cost method, we are considering the cost. That is the advantage. That is the advantage in LCM. And therefore reduces the computation as well as the necessary time to arrive at optimum solution. For example, if you follow northwest corner rule, after finding IBFS, you require nearly 10 iterations. After 10 iterations, you will arrive at optimum solution. But if you follow least cost method, after finding out IBFS, within 5 iterations, you can reach the optimum. That is the advantage in least cost method. The steps involved are: select the cell with the lowest transportation cost among the rows and columns of the transportation table. In this least cost method, select the cell in which we have the lowest cost in any row or any column. Forget about row and column. Wherever least cost is there, that we will allocate first to the minimum of row total and column total. Then if the minimum cost is not unique, then select arbitrarily any cell with the minimum cost. If it is not unique, if the minimum is appearing 2-3 times, then arbitrarily you can select any one and then allocate. Allocate as many units as possible to the cell determined in step 1 and eliminate the row or column in which either supply is exhausted or demand is exhausted. Once you have allocated in that particular cell where we have lowest cost, after allocation, the concerned row or column, anything will get exhausted. Block it. Then repeat the steps 1 and 2 for reduced table until the entire supply at different factories are exhausted to satisfy the demand. Like this, after taking the lowest cost, block the row or column. Then see the remaining cost, which is the lowest cost. There again, you make the allocation and block the row or column. After that, again you see which is the lowest cost. Again allocate, block the row or column. Like this you go on until and unless all the supply and demand are exhausted. Right? Example. I have taken the same table. The same table I have drawn here to show you how IBFS is found by least cost method. In this table, find out the lowest cost. The lowest cost is 3. You can see 8, 5, 6, 15, 10, 12, 3, 9, 10. So 3 is the minimum cost. So we allocate in the cell 3. In this 3 cell, row total is 80, column total is 150. So I am allocating 80 here. 80 here. So 150 minus 80, 70 will remain. So I'll cut 150 and make it 70. Here 80 minus 80 will become 0. 80 minus 80 will become 0. The row is exhausted. Block the row. This row I am blocking because row is exhausted. Now after this 3, what is the minimum cost? Here you can find the minimum cost is 6. Now allocate in this cell, right? What is the row total here? 120. What is the column total? 50. Whichever is less, 50 is less. So I am allocating 50 here. 50 minus 50 is 0 and 120 minus 50 is 70. Now here is 0. Column is blocked. Column is exhausted. So I am blocking the column. Now remaining cell, what is the next minimum? Next minimum is 5. In this 5 cell, again I'll make the allocation minimum. Minimum of row total or column total. Here row total is 70, column total is 80. Whichever is less, 70 is less. So I'm allocating 70 here. This will become 0 and this 80 minus 70 remains 10. When row total has become 0, the row is exhausted, blocked. Right? The next minimum is 10. In this 10, the column total is 10 and the row total is 80. Whichever is less, 10 is less. So I am allocating 10 here. So 10 minus 10, 0. 80 minus 10 is 70. That's all. Now only one unoccupied cell is left. In this unoccupied cell, the row total is 70. Column total is also 70. So I am allocating 70 here. This will become 0. Here this will become 0. Now you can confirm all the total, column total 0, 0, 0, row total 0, 0, 0, you have allocated. So each of the cell either occupied or unoccupied. The unoccupied cells are blocked. And occupied cells, you are having the numbers here. Here, sorry, here, this one. So 70, 80, 70, 10, 50. You can cross check also. 70 plus 50 is 120. 70 plus 10 is 80. Here 80. Column wise 70 plus 80, 150. 70 plus 10, 80. Yeah, 50. That's it. So I have explained you two methods. Northwest corner rule and least cost method. Again, if you compare northwest corner with least cost is better. Because it will give you the optimum solution will be near. If we take 10 iterations in northwest corner rule, only 5 iterations are required in least cost method. But still, it is time consuming. Then which is the most important method? The most important method is called Vogel's approximation method. Simply we call it as VEBA. VEBA is the most appropriate method because after finding out IBFS, you can easily get the optimum solution. Very easily you can get. But making the IBFS by VEBA is a time consuming. A little more time is required to find out the IBFS. Once you get the IBFS, at a stone throw away distance, you can get the optimum solution. Now this method is preferred over the other two methods because the IBFS obtained is either optimum or very close to optimum. The first advantage of VEBA is the VEBA itself, the IBFS by VEBA itself will become optimum or it will be very near to optimum. Most of the cases, IBFS itself will be optimum or sometimes one iteration or two iterations are required. Therefore, the amount of time required to arrive at optimum solution is greatly reduced. So, if you want to find out the optimum solution in a short period, then better method is VEBA instead of northwest corner or least cost method. Now, steps. The first step, compute a penalty for each row and column in the transportation table. This is the transportation table. In this, you have to calculate the penalty. Penalty means the difference between the smallest cost and the next smallest cost in every row and column. So you have to calculate penalty in the rows and also in the columns. The difference between the smallest and the next smallest. After finding out penalties in rows and column, find out the highest penalty. Round off that highest penalty, see whether this highest penalty is in rows or columns. Sometimes you may get in rows, sometimes you may get in columns. Suppose if you get in row, so round off that highest penalty and find out what is the least cost in that row. Whichever is the least cost, there you make the allocation and exhaust, block the row or column. Second penalty. Leaving that blocked items, again find out penalties second time. What is the difference between the lowest, smallest cost and the next smallest cost? Second time penalty we are calculating. After calculating penalty for rows and columns, find out the highest penalty. See whether it is in column or row. If you find out highest penalty in the column, round it off and find out in which column we are having highest penalty. In that column, what is the lowest cost? In that lowest cost, we make the allocation and then block the row or column. Third time, again you calculate penalty. Find out the highest penalty. Find out which row or column. In that row or column, select the smallest cost. Allocate in that cost, block the row and column. Like this, repeatedly you have to perform this operation. Then you will get the final solution IBFS through VEBA. These are all the steps required, right? Reduce the row. If the row supply is 0, eliminate the row. If the column desired is 0, eliminate the column. If both are exhausted, block both. Then recompute the row. Like this repeatedly you have to perform. Then what will happen? Though the VEBA method has the disadvantage of more computational work before the initial solution is obtained, it usually results with an assignment which has less transportation cost. Starting when we find out the IBFS through VEBA, it will require a little bit more computations because you have to calculate the penalty, highest penalty, least cost, allocate, second time penalty, third time penalty. It's a time consuming. But whatever time is consumed, the optimum solution is very, very near. Many a times the IBFS itself will become optimum. Sometimes one more iteration is required. That is the advantage of VEBA. Easily we can get the optimum solution. This ultimately helps in obtaining the optimum solution to the given problem in fewer iterations. Very few iterations are required to get the optimum solution if we follow VEBA. That's all. So in this video, I have explained you what are the methods available for IBFS, initial basic feasible solution, northwest corner rule, then least cost method, and Vogel's approximation method. In examination, you may be asked a theory regarding these methods. So watch the video twice, thrice so that you can be able to get the point. And while doing the problem, the concept will be very, very clear after listening, after watching this video. Hope you got my point. Inshallah, we'll continue our discussion on this theory in the next video. If you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we will continue in the next video.